Which of these triangles has the largest area? Okay, and we're given a bunch of triangles here. Well, oh, interesting. So, isosceles triangle with side lengths 10, 10, 1, something like that. An isosceles triangle with side lengths 10, 10, 5 has significantly less height, but more width. It would look something like that. Well, actually, that's more like the equilateral triangle. I guess I would guess it's the equilateral triangle. I like that they've called it an isosceles triangle with side lengths 10, 10, 10. It seems to be not the right word for it. So if I call that theta, I mean, the area is what? It's, call that x, y. If in general, if I draw a triangle, an arbitrary triangle like that, I'm just going to give two sides. I don't care what the third side, I don't really need that, right? Call that theta, and that's the height. So the area is base times height over 2. That's base. That's height. And the height is equal to, well, if I call that x, h over x is equal to sine theta. So h is x sine theta. So in all of our examples, the area is, the base, we'll call that one of the side lengths of 10. Call that also one of the side lengths of 10. And so theta is the angle that's opposite the third side in each example, whether it's 1, 5, 10, 15, so on. So the area is always 10 squared over 2 times sine theta. So we simply want to maximize sine theta. That's maximized at 45 degrees, right? But are any of these... None of these are a right triangle. So what do these look like? There's the equilateral. So here, theta is equal to pi over 3. And when I have 10, 10, 15, like this is, so the equilateral is certainly larger than the other two triangles with the smaller third length. Almost certainly will have a larger area than the one where the other length is 19, right? If the other length is 19, then we have a triangle with the base here and the other side like that. But it's in fact, it's very close to, it's a very narrow triangle. How do I compare it to the one 10, 10, 15? You know what? Well, 10, 10, 15, that's very close to a right angle triangle, right? This is 10, 10, 14.1. And that's going to be about as close as you're going to get to of these examples. Like this is very close. If the side length is 15, we're only just moving over here. So I think the answer is going to be D, 10, 10, 15. And you can see that, you know, we have sine of pi over 2, which is 1 for the right angle triangle. Yeah, I probably should have honed in on that a little bit quicker rather than getting jumbled up with the, even with this formula, it's probably not really necessary. I mean, a right angle triangle is going to be the one that gives the largest area. That's, I don't want to call that obvious, but yeah, it's about as close to obvious geometrically as you can get. And this is very close. This is very close to a right angle triangle. So yeah, that'll be my answer. I'll let you know if there's a mistake somewhere though. Thanks for watching.